There's got to be an easier way.
Hello. This is going to take a little while, but try to keep it entertaining. We'll have some fun, so don't worry too much. Now, this video is going to be a little bit different to some of my other videos that maybe you've seen before. You probably haven't, but anyway. So for the last few years, I've been doing my PhD in computer science, machine learning, AI type stuff. But I really started out when I was a kid doing electronics and electronics projects. Actually, from Australia, you know, maybe the Fun Ways projects. You can see how well loved that is. And over the years, I've done quite a lot of projects. I've documented very few of them. I went through a phase where some of them ended up on Instructables back when they had good prizes, but I've always struggled to actually remember or be bothered to document my projects. And with the recent videos I've been doing on deep learning and PyTorch, it kind of got in the groove, and I thought finally, I've recently just submitted my thesis for review. That's what we do here in Australia. I submitted a couple of weeks ago, about a month ago actually. So yeah, I haven't had a lot to do except for a little bit of consulting that I've been doing. Call me if you're interested. So I thought, I'm finished, I've submitted. I haven't done the project in a while because the thesis just keeps getting in the way. So I thought I want to do another project. So I've got my notes here. I've gone through the process and I'm just going to tell you all about it. This project at this stage is not done whatsoever. This really is just the beginning. So I'm just putting this video out there to get a bit of feedback. Maybe some people are interested and want to do something similar. So what is it? Well, a few years ago, I was helping some ecologists up in Queensland. It wasn't a part of my PhD. I was just helping them because they were starting to use some machine learning object detection techniques. And I'm not an ecologist at all. I've got an electrical engineering, computer science background. Through them, they sort of taught me all the sorts of things they were doing. What they were doing was a type of ecological surveying. So there's a huge number of types of ecological surveying that you can do depending on where you are and what you're looking at, what sort of data you're collecting. Some of them are very manual, some of them are very hard to automate, but sort of relevant to us are ones where you either set out a camera.
Another way to understand your habitat is to know what types of animals are using your habitat. So there are lots of different ways to do that. Some people use webcams or motion sensing cameras or even traps.
And you want to extract some information from that. If you're using a camera to record animals in the wild, you would set out your cameras and then you would take your data back and then really, usually, manually have someone look through the image data, log or note down whatever it is you're looking at. But what they were trying to do and what other ecologists are trying to do, if it is possible, is to use machine learning or object detection to automate that process. So if you would have to sit down and watch, hundreds of hours of footage, log the type of animals or the type of species that appeared, you would hopefully now just be able to run that through a trained model and it would extract all that information for you. So in their case, they would set up a camera to record whatever it is they were recording for. One thing you'll note is that a lot of the video footage contains nothing. Upwards of 80 to 90% of the footage contains absolutely nothing. Now, it's important that there was nothing there, but you don't need the video footage to tell you that. So one of the things that I wanted to explore and look into was the use of edge compute and real-time processing of images in order to not only speed up the whole process, but allow you to potentially record for longer and get more timely data. So the brief, I guess, of what I was trying to do was to set something up in a single location indefinitely and then just have it give me the information that I wanted. So this sort of real-time edge compute is not new. Even in ecology, there's some work on that. There are kind of some products out there. There are even, I think, camera sensors these days that have neural network accelerators in the same chip, or maybe adjacent to it, I'm not sure. And even in ecology, this sort of edge compute is starting to be used. I even found a master's thesis that was doing something pretty similar to this. They weren't using any sort of neural network accelerator. They were doing things a bit differently to how I would do it. I don't want it to turn into an impromptu peer review, but some things in that were a bit funny. I'm not entirely sure how you do reliable object detection on a 96 by 96 pixel image. But anyway, we're going to do it ourselves. So like I said, this is not the conclusion of the project. This is just getting a starting point, sort of arrived at my MVP, my minimal viable product. And we have something that works. I wanted to share that to get some feedback and also maybe inspire some others or get some others interested. As such, this isn't really a tutorial, but I will sort of point out the important points in how I got to this stage. All right, so what is in here? So I actually bought a Nvidia Jetson Nano a few years ago when I first had the idea. It is a bit of an old computer, even when I bought it. These days, the more modern ones are a lot more powerful. So I think the Jetson Orin is the new one. That Orin 16 gigabyte version has like 100 tops or 100 trillion operations a second. The Jetson Nano here is like half a top, but this is a lot cheaper. These days you can get like a Raspberry Pi 5 with a neural network accelerator. I think there's the Halo 8 or Halo 8L. I think there's 2 versions, each with, I think, 13 tops or 26 tops. And that whole package together with the Raspberry Pi probably costs about the same amount and probably uses less power too, which is important in this sort of system. But really, how I've got this running, we really can swap out these components pretty quickly and easily. So as I said, I want to leave this somewhere indefinitely, and that means we need some sort of power source. So that means some way to charge the battery, and the easiest way to do that, of course, is with a solar panel. So here is just a 30 watt, 12 volt solar panel that I got. The battery I'm using is actually it's a 9 amp hour, 12 volt lead acid battery. I'm using lead acid just because it's cheaper for the same capacity. According to the datasheet, it has like a 20 hour capacity of 450 milliamps. That is, you can draw 450 milliamps from it for about 12 hours before it gets flat, though you don't really want to drain a lead acid battery to 0%. If you want to cycle it, apparently you should only drain it down to like 50%. So that gives us a sort of target of 450 milliamps at like 12.5 volts for 10 hours. That's about 5 to 6 watts for 10 hours. In order to actually charge the battery and power the system, I'm using a DF Robot solar power manager for a lead acid battery. I really like this module. It basically does everything for you. It has maximum power point tracking. I won't get into what that is. It also charges our lead acid battery and provides a number of regulated outputs. So it's got 2 USB outputs and a 5 volt 5 amp output, which is actually the same output, but it also has a separate 12 volt 8 amp output. So I'm only using the 5 volt 5 amp output to power everything. Though if you need something like LED lights for an experiment or something, you can use that 12 volt output as well. As this is going to be out in the elements, we obviously need an enclosure that's going to be waterproof. I just got this IP67 enclosure from eBay. It has a clear lid because the idea is that we want to put a camera inside. It also usefully has a removable sort of mounting plate at the bottom that I can screw everything down to and just lift out the whole plate when I want to tinker around with it. So those were the main components I got first. And I just wanted to wire them all together quickly just to see if it works. Put it in the sun, no surprise, it all worked. I was a bit impatient at this point, so I kind of soldered together a little DC barrel jack for the Jetson. I plugged it into the regulated 5 volt output from the power manager just to see if it would boot. And, I guess no surprise, it did. Yeah, I was a bit impatient, so I did drill a hole in the back so I can just feed in the solar panel cable into the box and like close it all up and see what it looks like. That was a bit of a mistake. I did need to enlarge the hole later. So I just used a 2-pin sort of marine DC adapter, DC plug. I'm not entirely sure what it's called for the solar panel to get the power in. So I needed to drill out that hole with a spade connector, which wasn't pretty, but it did work in the end. And I sort of just press fit that connector in there and soldered the solar panel cable to the other connector. The plug that actually went into the box didn't quite fit. It sort of hit up against that base plate. So I had to use all of my 3D design skills to print a little spacer that I could sort of put in there. That just gave us enough clearance to actually feed the cables into the box. So I was making progress, so I thought I'd just connect a camera now. I was just using a Raspberry Pi V2 camera that I had. I've had this for like 12 years or something, so it's definitely seen better days, but I just 3D printed a little mount. It has a bit of a weird shape because for some reason I didn't think at the time that you could just screw from the bottom into the base plate. So I was thinking of, screwing from the top, and so you got this very snappable shape here. But anyway, as you can see, I eventually did get a replacement, and I'll talk about that later. So just using a Wi-Fi dongle to connect the Jetson to internet, I just put everything in the box and set it all up. I used Motion, this open source security system that you can put on like a Raspberry Pi or something like that. It has a pretty unfortunate name. It's pretty hard to find, but if you just Google Motion GitHub, you'll find it. Basically does motion activated recording. So it'll stream the video, but it also captures events when there's motion. I use this as a sort of test just to see that everything was working, and it was. So on to the next stage. Unfortunately, at the moment, it is winter here in Victoria, Australia. So we don't get a huge amount of sun. It's probably the worst time to do a solar powered project, but we did get a little bit of sun here and there. So I could test and verify that it was all working. With that all done, I wanted to create the frame or the structure that it all gets mounted onto first. To actually connect the solar panel to everything, I created basically a little frame from 2020 T-slot extrusion. So I made like a little H frame to bolt onto the back, which was kind of difficult. It was hard to get my hand or a tool in there to actually tighten it up. It did come loose quite a few times as I was trying to do it. I eventually found like one of those flat sheet metal spanners you get with like a 3D printer, and that was able to fit in there, and I was able to get it tightened up. By the end, I kind of had like this little solar panel shield. If you ever want a cosplay costume idea, maybe that would be a good next one. I eventually got a little aluminium hinge to put on the top to mount the solar panel, but that took ages to get there. So I was going to try and mount the solar panel on the top somehow, but I just gave up and just put it to the side for now. The main shaft you can see here is just a long piece of 2040. In order to mount the box to it, I didn't really have a plan initially. I kind of just went down to Bunnings, the hardware store, and looked around for something that might be suitable. I eventually settled on these steel straps or support straps that you use for framing, I think. So they kind of had a nice strength to them, and I was able to bend them and basically screw them down to the blind holes that are in the back of the box. And the idea was basically to sort of hang that onto the 2040. In order to actually hold it on to the frame, I just used some T-slot nuts that sort of would just go in there, you know, the ones that screw in. So it kind of just hung there. There was quite a big gap that I eventually 3D printed some little spaces that sort of just slotted in there. I didn't have any way to mount the solar panel, as I said, so I just put it on a chair. I forgot about it for a few hours and ended up leaving it out in the rain, but it all worked. You can see I used a old umbrella stand as a sort of base for that. Nice heavy base. Because again, I didn't really have a plan for that at this stage, but you know, MVP, whatever works. So we really could just stop there and put our object detection on it, but I wanted this to work, as I said, indefinitely, and that sort of meant we had to handle situations where we would lose power. You know, that might be for days, because, you know, at the moment here in Melbourne, we have days where it's just raining non-stop, and as I said, the battery will only provide power once fully charged for about 10 hours. So the next stage was to create what I'm calling like a box manager. What this would do is basically sense the battery voltage and switch on and off the Jetson depending on power level. You could probably put the Jetson to sleep during that time, but I wanted to just switch it completely off. So I just used an Arduino Nano and some additional sensors that was basically going to be on all the time, but should draw a low enough power that it wouldn't drain the battery completely. So I did some tests with the Arduino Nano and the current voltage sensor. I can't remember what one it was. It was a pretty common one. Measures current and voltage, and will also calculate a power output as well. I also have a little LED or OLED screen that would just output the voltage and power. I will eventually have another one as well, because I wanted to monitor the solar panel output as well, so I could sort of see what the power output is and position it correctly, I guess. For the initial test, I just had the current sensor just monitoring its own power use, which I thought was pretty funny. But once I had that working, I sort of shoved it in the box and just had it measure the battery power usage and voltage while it was running motion and streaming over Wi-Fi. I was using about 3 watts. So I built up the REST box manager board. I used just a long breadboard or a baguette board, and I connected the Arduino, the current sensors, the OLED screen, the real-time clock, which would be used to turn the Jetson off at night and then on in the morning. I also wanted to connect like an SD card as well to log the power during the day, just to see what the power usage and power production was. But it seemed like everything was getting a bit too much for the Jetson Nano. I kept running out of space, so I sort of left that off for now. I think in the future, I'm probably going to upgrade to like a Teensy or something with a lot more memory, because there's a lot more functionality that I'd like to put into that I couldn't really do at this stage. So yeah, I just simplified everything for now. The 2 current sensors, you do need to make sure you short out one of the address pads so you have different I2C addresses. But once that all worked, I decided I'll solder it up. So just using a piece of prototype board, I was just going to solder some female header pins and sort of just plug everything in there. So at this stage, I realized it must have been a long time since I'd done any soldering, because I only had this tiny piece of solder. So I had to go down quickly to my place of last resort, really, to pick up some. So when I'm soldering prototype boards, I like to use just solder bridging mostly. It's just pretty quick and allows me to modify it quickly as well. If you're smart about it, you can usually get a pretty good trace out, you know, with power rails and signal rails and all those sorts of things. I was in a bit of a rush. I didn't really plan it out that well, so I had to use more jumper wires on the top than I would have liked to, I guess. But it was fine. So I had the Arduino Nano, the OLED, and the 2 current sensors on there, as well as the real-time clock. Again, I didn't really plan out where in the box it was going to go. I did leave a bit of room near the solar panel manager and charger. But while just playing around with it, I had a really good idea that it seemed to just fit really nicely over the top. So I drilled out a few holes and just using some standoff spaces, kind of screwed it on the top. I actually think that looked really good in the end. It looked pretty neat. I think in the future, I definitely want to make a PCB with the sensors on it. Probably not the microcontroller. I might still plug that in. But there are actually some header pins on the DF Robot Solar Power Manager that you can probably just plug in instead of using the terminal blocks on it. And that should make everything really nice and clean as well. So with that all done, I thought I finally should probably try and mount the solar panel on it. I still didn't have the aluminium joints, so I just 3D printed out a really bulky hinge and just used a piece of threaded rod that goes in there and tightened it up. Had a little tension handle on there as well, so I could tighten it up manually as well. Unfortunately, it did start to crack on the layer lines. So I had to come up with a temporary solution that would work for now. At this stage, I think it looked pretty cool. It looked pretty close to what my vision was for it. One issue at this stage that I did notice, and you may have noticed through some of the footage, is that the box lid isn't really that clear. If you're looking at like the screen, you can see it does distort it quite a bit. And I wasn't sure if that was because of scratches or because the actual lid was not perfectly flat. I think it was a molded plastic, and so it wasn't optically clear. So I thought maybe if I can just sort of sand it or smooth it out a bit, polish it up, I might be able to get a better optical finish. So I went out and bought some acrylic polish. I don't know why I thought the box lid was acrylic. But I put it on the box lid and I sort of polished it up a bit. And I thought, oh yeah, that kind of looked like it's making a bit of an improvement. And so I kind of just jumped to sanding the whole box lid flat, which was a mistake because it's not acrylic, it's polycarbonate, and the acrylic polish did absolutely nothing for it. So I was stuck with a box lid that was even worse than before. But I thought, oh, I'm smart. Apparently you can use acetone vapor smoothing to polish polycarbonate smooth. And I thought, oh, I've done vapor smoothing before with ABS 3D prints. I can do this, no problem. So I put a tray of acetone on my 3D printer bed. I sort of suspended the box lid above that and I heated up the bed. And after a while, it did look like it was working. So I thought, oh, perfect. I've fixed it, no problem. But very quickly after that, things went downhill fast. I think I had the temperature up a bit too high and there was a bit too much condensation of the acetone on the lid. And so we started getting these cracks forming in the lid.
It's not good.
Not entirely sure why that was happening. I think the molded lid probably had a lot of tension in the part on the surface. And so the acetone dissolving that surface layer sort of released the tension and the plastic kind of separated in all these spots, creating this cracked pattern. But anyway, we kind of went from bad to worse here. So I was contemplating buying a new box for like $50, but that wouldn't really fix the problem I was having with the distortion from the lid. Apparently though, this is a known problem because with something like this GoPro underwater housing, you can see the main housing is made from molded polycarbonate, but where the lens is, it's actually a separate flat piece of plastic that is very smooth and very flat. So obviously this is a known thing. And I thought, oh, all right, I'll just do that then. So I got a piece of acrylic. I didn't get polycarbonate. I wasn't too worried about it getting scratched up at this stage. And if it did, you know, I've got this now and I can polish it up whenever I want. So I ordered that online. And while I was waiting, I thought maybe I'll start with some of the software. So the first thing I wanted to do was just to properly code up the Arduino box manager. So like I said, the main function of this would be just to monitor battery and solar panel power production, power usage, and have it shut down the Jetson when it dropped below like 50%. 50% I think for this battery was around 12 volts, so I kind of used that as my target. In order to power on the Jetson, there is an actual jumper pin. I think it's underneath the main carrier board on the dev board. So there's the jumper that you need to put in so that it doesn't boot up on power up when it receives power. And there's also another pin that's basically the on-off pin that if you short this, the Jetson will power up. Pretty sure all it's doing is just pulling the pin to ground. So I probably could have just used a transistor or something to do that. I went a bit overkill and just used a relay instead because I just didn't want to break anything. I had a little relay board as well. Unfortunately, that only worked with, I think, a 12 volt input signal. So I just took it off that and made up my own little board. So just toggling that relay will boot up the Jetson. Unfortunately, that same pin will not shut down the Jetson. So I need to come up with another way. So the idea was to just have a single pin connected from the Arduino to the Jetson, and the Jetson would basically just monitor this pin. I'll just have a service running, and if that pin goes high, the Jetson will then sort of issue a shutdown command. And this whole system was a bit nicer and cleaner than just disconnecting power from the Jetson, allowing it to boot correctly and allowing it to shut down correctly. Ideally in the future, I'd use a proper form of communication, some serial communication, and again, using the Teensy, which has 3.3 volt logic, would probably be a good idea. In order to manually turn the Jetson on and off, I had a push button on the Nano, and that would basically toggle on and off the Jetson depending whether or not it was in an on or off state. I 3D printed a little cover to go on the top of that with a little hole in the middle, just so that I wasn't accidentally turning the Jetson on and off when I was sort of fiddling around in the box. I had to use like a pin to sort of purposefully turn it on and off, which I thought was a clever idea. And like I said, I was using the real-time clock on the Arduino Nano to know when to turn the Jetson off at night or on in the morning. It would also, as I said, shut down the Jetson if the voltage on the battery got too low. Note that because the battery is connected to the charge circuit, the voltage across the battery isn't actually the battery voltage, it is the charge voltage. But if the voltage does drop below 12 volts, then that's most likely because the battery voltage is low and there's no sun. Though you do need to take it into consideration when turning on the Jetson during the day if we've got enough power, because if the sun suddenly comes out, the voltage across the battery might jump because it started to charge. I didn't really worry too much about that. I just made sure the turn on voltage was high enough so that it wouldn't just turn on and then maybe draw too much power and turn off. All right, onto the actual main point, the machine learning object detection. I left this to sort of last. I wasn't too concerned. I did have a fairly good idea about what I was going to do here. At this stage, it wasn't going to be anything too specific. All I wanted to do was get a off-the-shelf pre-trained object detection model and just run inference through it. So I just used a tiny YOLO V7 model from a GitHub repo that I've used before. You can really use whatever you wanted, Ultralytics or whatever. In any case, you export the model as an Onyx file with whatever you're using, and it really is just a drop-in. So like I said, I was just using a pre-trained model, but if I wanted to fine-tune it on a specific data set, again, it would just be a drop-in, change the actual file name for the model. I'm using Onyx and Onyx Runtime on the Jetson. In order to install it on the Jetson, you need to manually download the wheels for Onyx Runtime from the Jetson Zoo. Just a weird quirk. It was pretty straightforward though. At this stage, I kind of planned to keep using motion. The idea being that motion would run with less power and it would stream the video from the camera. If there was a motion event, it would save frames, and then we'd have a separate service that would run the object detection and just basically watch out for any frames that were being saved from motion as a motion event. If any of them contained an object that we were looking for, so a target object, it would log that detection and also save the video frames and delete any frames that didn't contain what we were looking for. This way we can sort of filter out frames and keep what is relevant. Again, this is to save power, because the Jetson can be quite power hungry when using the GPU accelerator, though it does have hardware power limiters. So you can put it in a high power or a low power mode, either 10 watts or 5 watts. And even at the 5 watt level, you can still run inference at about 10 frames a second with the tiny YOLO model, which really is more than enough. I did create another version where it would just stream frames straight from the camera and just do object detection on every frame, but only have it running at like 1 frame a second. And that actually seemed to work okay and not draw too much power. So if relying on the motion detection is going to be a problem, that does seem to work quite reliably and not use too much power. All right, with all that working in the box all set up, it's time for the finishing touches on there. I got the acrylic sheet for the front panel. It was a lot clearer than the original box lid, so I'm glad I did that. So in order to fit it in, I just cut a hole in the old polycarbonate lid and just glued the acrylic on there, just using some plastic glue. I did a bit of a test to make sure it would hold. There's quite a lot of surface area between the two, so I wasn't really worried about that coming undone. I also 3D printed a little frame to go around the edge, just to sort of hide all my sins. I had to 3D print that in 2 parts because my 3D printer's not big enough, and just sort of slotted it in place. And I think the end result was really nice. So finally, the aluminium hinge joints arrived. They're just designed to sit on a single like 2020 and interface with another 2020, but I was going to use 2 of them. So I drilled out the threading that was already in there and put a longer M5 bolt that would go all the way through so I could clamp it on both sides. I 3D printed a little handle, and that all seemed to work really well. I could tilt the solar panel forwards or backwards. I am limited to pointing it only forwards or backwards with respect to the camera at this stage. Ideally, here in the southern hemisphere, you point the solar panel north, which did mean that my camera had to either be pointing north or south. So having a sort of more universal hinge so I could point the solar panel any direction might be useful in the future. So I also got a new camera. As you can see, I got the Raspberry high quality camera. It's like a 12 megapixel camera. Record video at 4K, like 30 frames a second, which is overkill for what I was doing at the time. I'm not streaming video at 4K yet, but that might be useful in the future if I want to take photos of a species when it's detected. So with this camera, you do need to get a separate lens. I just got the wide angle lens. It does also come with a telephoto lens, but I guess any sort of lens that fits in that C clip or C connector, I don't know what it's called, you could use that. To get the camera working with the Jetson was a bit annoying. There's a lot of conflicting information online about how to get it working with the Jetson Nano. I eventually worked it out. It's a lot simpler than I think people make it seem. Unfortunately, you do need to remove the R8 resistor on the back of the camera for the Jetson. This was really nerve-wracking, but it doesn't work unless you remove that, only if you're using it with the Jetson. And then all you need to do is configure the Jetson I/O for the CSI connector to this camera sensor. I think it's like 477, IMX 477. People were saying that only works natively with the Raspberry 2, but now if you get the new image for the Jetson Nano, it does work with this newer camera as well. Also, because the Jetson Nano only has a Ubuntu image of Ubuntu 18, it can't use a more modern version. I am kind of limited in my Python version, and so the OpenCV version I was working with didn't seem to really work well with GStreamer, taking the images from the camera, and Motion didn't really seem to work that well either with the camera, so I ended up having to hack around and basically just create like a virtual device with GStreamer, and that seemed to work fine for both Motion and OpenCV. I don't know if I needed to do that, but I don't know, I made it work. All right, so I've done a bit of testing with the system at various stages. I even streamed video using my webcam to the Jetson of my street, just logging cars going past. But now I wanted to do sort of full-scale tests. Unfortunately, there isn't any wildlife in the little courtyard we have here, except for the rat that keeps stealing the mandarins from our mandarin tree. But I think that comes out at night, and so I can't really detect that with this camera. So I drove it over to my parents' place. They got a much bigger backyard. There isn't a huge amount of wildlife there either, but there are magpies and various birds that do hang around there. So I was hoping that the motion detection would capture them because they are quite small in the field. The idea was that it's going to log the frames and detections to a USB, and that you could kind of come to and fro the camera at various times, take out the USB, plug a new one in, take the USB away, and analyze the data. I know, yes, you could put like a 1 terabyte SSD in there and, you know, log as many video frames and as much video footage as you wanted. And in certain situations, that might be what you want. If you're just going to leave it there for like months on end, that might be a good idea. All right, so to set it up in my parents' yard, I just found a nice spot that I thought would get enough sun. Unfortunately, it's winter, and so the sun is quite low to the north. And in my parents' backyard, there's like a line of trees that are like perfectly blocking out the sun for most of the day. And on the solar panel, the sun was really sort of speckled from the leaves of the tree, which isn't really ideal for a solar panel. Again, it wasn't really ideal, but I was getting like 20 watts peak on a sort of overcast day when the sun came out. So I was hoping there would be some days at least where the battery was getting charged, so I'd be able to get more than just a single day's worth of detections. Again, at this stage, I'm just using off-the-shelf object detection model, so it's going to detect a whole bunch of things, whatever is in the Coco dataset. But one of the categories is birds, so I'm just going to hopefully get some birds. So it did look like it was going to get enough sun in the next few days from the forecast, or at least I thought when I was setting it up. Unfortunately, the very next day, the forecast changed, and it was going to be overcast and raining for the next few days, which was a bit annoying. When we finally did get a sunny day, I did go over to see what was going on. It did seem to turn back on. It was on when I was there. The battery voltage was a bit low, but we were getting a good amount of power, but we still got a few rainy days. I just kept leaving it until we got a few sunny days in a row where I was sort of confident they would turn back on and get some captures. So I left it for a week in total, just facing the backyard. I didn't really check what we were detecting, if we were getting any detections, which probably was a mistake. But that part of it did work in the end. Unfortunately, I forgot to install the real-time clock battery on the Jetson. So the Arduino real-time clock worked fine, but the Jetson Nano has a spot where you can solder on a sort of coin battery holder, which powers its real-time clock. And I did know this because I saw on a forum somewhere, someone had the same problem. When I was searching some other thing, I was like, oh, make sure you install a real-time clock battery for the Jetson. But I obviously forgot about it because while I was here, it was connected to the Wi-Fi, so whenever it would boot up, it would get the correct clock time. If you're going to put it somewhere where it's not connected to Wi-Fi, you know, like in the middle of nowhere where it's going to be, you're going to want to install the real-time clock battery. So what seemed to happen was that whenever it shut down and reboot, it kind of just Groundhog Dayed to the last time that it was connected to Wi-Fi. So I set it up on like the 26th, and basically all of my detections are on the 26th. So I was a bit confused. And we did get some detections from different magpies and some other birds, but they were all unfortunately logged to the 26th, and I couldn't really separate them out in any way. I know they were on different days because at least one time we got like a currawong and it had clearly been raining, and it wasn't raining on the day I set it up or even the next day. So it must have been a few days later. So I think I was getting detections throughout the week, but unfortunately I have no idea when they actually were. So yeah, definitely going to do that in the future. But this is why we do incremental tests, because I can imagine if I'd set this up in the middle of nowhere for a month and got back and all the timestamped detections were wrong, I'd be pretty annoyed. That's really where I'm up to at the moment. As I said, there's a few improvements we can make here. The next thing I want to do is probably incorporate some sort of wireless link. Like I said, something like LoRa, so I could just stream detections whenever they happen, and I'll have some sort of receiver on my end, and that can just pick up the detections as they occur, so I can sort of log them in real time on my computer, which would be cool. I also, as I said, want to put all of the Arduino, or the teensy as I want to get, and all the sensors and everything on a separate PCB. I really don't like the jankiness of the connectors. I really hate those header pin connectors that you use for breadboards. I really don't like them because they come loose so easily. I also want to make sure that I'm using an SD card to log the power, production, and usage. I think that would have been pretty useful in the week-long experiment I ran. Just inform me whether or not my expectations or thoughts actually coincide with reality. Longer term testing is definitely something I want to do. I'm not sure about the legality of setting this up in like a state park here in Victoria. I'd like to set it up for like a month ideally and just have it stream detections from some native animals. Online it does say you can set up trail cams. So I don't know if this counts as a trail cam. I guess it's kind of doing the similar thing. You can get it to filter out images of people to ensure that you're not capturing any images of the public. But yeah, I don't know if anyone knows. Let me know if you know. I think using the Raspberry with the Halo neural network accelerator is probably something I'm going to be doing in the future. Unless there is some interest in people having this of their own and they want me to make one for them, I'm open to any sort of research projects in the area. Like I said, I do come from an academic background and I've helped ecologists before. But as I said, I'm open to feedback at this stage. I will create a Discord for this project and I guess my future projects as well. So if you have any questions, if you want to do something similar, then let me know and I'll be happy to help. So I just want to close off with, I guess, just some ideas. I don't want you to think that this is all you can do with this sort of technology. I think there's so many things that we could do, wireless link being one of them. You could also do pose estimation. I really want to do like pose estimation of a kangaroo to get like the wireframe, and then you could like stream that over a wireless link, and you could like reconstruct like the wireframe of the kangaroo in like Unreal Engine and get like a real-time visualization of like kangaroos out somewhere. I thought that would be really cool. Or you could do the same thing with like fish. If you had like stereo cameras, you could get like a depth estimate and even calculate the size of the animals and like a 3D position even, so you could get 3D render of the animals in Unreal Engine. I think there's a lot of things you could do. So yeah, let me know if you're interested. Bye-bye. What the fuck? What the fuck? It's literally biting me. It's trying to stab me too. Get out of here. He's over there now. Okay, stop.